Hi everyone, and the objectives of this video are to observe the method of mesh analysis to assist in analyzing our KVL problems, and to provide a relevant example of the application of a mesh analysis with respect to an electrical engineering problem. So before we begin, we need to define what a mesh is. A mesh is a loop which does not contain any other loops within it. So recall before when we were looking at loops, many a time we would have loops which themselves could have loops within them as well. A mesh, however, is a loop which does not have a bunch of loops within it as well. Now the procedure for mesh analysis is quite simple. Firstly, you assign currents to each mesh. Then you apply the Kirchhoff's voltage law to each mesh, and then solve the simultaneous equations to get the required unknowns. So to look at an example that illustrates this, we have the following circuit diagram here. Two voltage sources, a 10 volt and a 5 volt source, and three resistors, 20 ohms, 10 ohms, and 12 ohms. So if you look here, there are actually three loops. There is a loop that goes like this. There is a loop that goes like this, and there is a loop that goes like so. However, we are looking at meshes, which is a loop which does not have a loop within it, so this giant loop is negated. So you have these two loops right here, and we will assign currents to each as per our first step of the procedure. So let's say that this is I1. Let's say that this is I subscript 2. So now that we have assigned currents to each mesh, we need to apply the KVL to each mesh. So let's call this our mesh 1,